In this video tutorial, we are going to build the chart that you see on your screen. It features custom org chart nodes, which can be edited and support custom images. You can create interactively new nodes with right-click, as well as move the nodes along the hierarchy. For the project, we use an empty diagramming application, which we created in a previous video tutorial using Webpack and the MindFusion Diagramming library for JavaScript, which we installed from npm. We edit our code behind file by declaring the org chart node class. It derives from TableNode, and you can read about the TableNode class, as well as study its members, from the online documentation. We create a table with 3 rows and 4 columns, and we set some font properties to those cells that are going to render text. Before we continue, we need to declare some namespace mappings. We need to import not only the diagramming, but also the drawing namespace. Now we are going to add a special method for fine-tuning our cells. We call it configure cells, and there we make some of the cells impossible to edit by declaring a property, which we name editable and set it to false. We do some text formatting with the text padding property, which is an official property of diagram item, from which diagram cell derives. Finally, we declare cells that indeed hold text as editable using our new property. Last but not least, we call the configure cells method in the constructor of the org chart node class. Now we add some appearance settings. The properties are defined in the table cell class. You can check the members list. We set caption height to 0 because we plan to use no caption. We change the handles style to move only. The handles are the UI gauges that appear on a diagram item and allow you to interact with it, move it, resize it, rotate it, and so on. We also hide any cell frame by setting the cell frame style property to none. Last but not least, we specify the brush for the node and its shape. The brush is used to paint the node interior, and the shape could be ellipse, arrow, triangle, and so on. Now we are going to declare a property called full name for our org chart node. We also declare a property for the image location, for the comment, for the ID, and for the title. Now we are going to add some default values for our custom node. The full name is name, the title is title, and the ID is not defined. For the image, we prepare an image called placeholder.jpg. Now, since we use Webpack, we have to preload our images. We start with the placeholder. We import it at, and then we assign the image location property to the imported image. We continue with another utility method, resize. There we make sure the image as well as the text fit well into the table cells. We use the resize to fit text method, which is part of the official diagramming API, and we also do some calculations to make sure the image fits well. The resize method uses another method to assign employee data and the correct place of the node in the hierarchy. The method uses the properties we declared to assign the text in the table cells. It also calculates the ID of the boss for this employee and applies some styling on the table node. The setHierarchy method determines the level of the node into the organization. If the node has no boss, this is the second level in the hierarchy. From then on, we call recursively the method until we reach the end of the hierarchy. Once we know at each level this node is, we can set its color with the setColor method. The setColor method just assigns a predefined color to the node based on how deep into the hierarchy it is. We have chosen colors for 6 levels of hierarchy. After that, the nodes are painted with the default gray color. We add 2 more utility methods, addChild and removeChild. The first one checks if the node provided as a parameter is already among the child nodes of the current node. If it is not, we add it. The removeChild method finds the position of the specified node, if any, and removes the node from the array of child nodes of this org-chart node. The last 2 methods we will add to the org-chart node class are resetHierarchy and isChild. The resetHierarchy method looks over the boss for each node and rebuilds the tree. The isChild node simply checks if the node provided as parameter is found among the children of the current node. With that, the declaration of our custom org-chart node class is finished, and we are ready to build a simple org chart with such nodes. We declare 3 variables, diagram view, diagram, and tree. The diagram view is bound to a canvas element in the web page. The tree variable represents an instance of the tree layout class. You can check the online documentation for the properties of this class. We use the layout direction property of the tree layout, which we set to top to bottom, and link type, which we set to cascading. We add 2 more settings to the diagram view. First, the behavior will be custom, and second, we turn on auto scroll. This means the view will scroll automatically when you drag a node outside the currently visible area. We continue now with the first event handler for the diagram. We want to create a new org chart node when the user clicks the right mouse button. The event data gives us information for both the button that was clicked and the mouse position. You can check the events in the online documentation. So, when the right mouse button is clicked, we add a new node to the diagram and call the arrange method. The arrange or arrange animated method applies the selected layout algorithm, in our case the tree layout, to the items currently added to the diagram. Arrange animated uses animation in the process of arranging the graph. The next event we are going to handle is animated layout completed. In the event handler, we call resize to fit items on the diagram instance. Resize to fit items is a very powerful method, which resizes the whole diagram area so every item fits in. The node selected and node deselected event handlers do a simple thing. They change the z-index of the node, which either pushes it to the top or sets it to the same level as all other nodes. When a node is deleted, we rearrange the diagram. When a link is created, we also rearrange the diagram. The situation is a bit more complicated when a link is deleted. We need to get the destination of the deleted link. This is the node the link pointed to, and set its boss to undefined. We also need to reset the hierarchy, reset the text cell that listed the employee's boss, and rearrange the organization tree. The node modified event is needed for the case when we drop a node over another node, and this creates a link between the two. The dropped node becomes the subordinate of the node it was dropped upon. Actually, there might be multiple nodes that are located under the dropped node, so we need to find them all. We use the diagram's getNodesAt method to which we provide as argument the point where the node was dropped. After that, we create a link between the dropped node and the node beneath it. We also reset the hierarchy, rearrange the diagram, and resize it to fit the newly arranged items. The last event we want to handle is the Enter in Place Edit Mode event. It is raised when the user starts editing the cells of the org chart node. We get the control that was edited and set the correct placeholder for it. We learn which cell is edited by the event data. We add a few more photos of employees to use in the chart, and we are ready to create some nodes. We create 5 nodes, which use the photos, and we specify the title, name, and comments for those guys. We also set the image to point to the newly imported images. We create the links between the employees. We use the Create Diagram Link method of the Diagrams Static Factory class. Now we need to stop in-place edit of the diagram and set the behavior to modify. Modify allows the user to modify existing items, but does not allow creating new ones by dragging with the mouse. This is right, because we create new nodes with right-click. We edit the Webpack config file to include support for the various image files. Now is time to run our application. We open a terminal in the project folder and type npm run dev. This compiles the sample and starts a web server. And here is our chart. We can add nodes by right-clicking on the boss. When we delete a link, the node becomes detached, and we can assign it wherever we want in the hierarchy. With that, our tutorial is finished. Thank you for your attention. If you've made it so far, you can download the project from the link in the video description. Thank you for your interest in MindFusion Developer Tools.